Yes. Okay. In the continuation of the yesterday's topic that was discussed, that as Boolean algebra. Okay. So Boolean algebra means it has to be a lattice. Furthermore, it has to be a complementary lattice. With it, one more condition should be satisfied. That is distributive lattice. Okay. Now in this class, we can enter into discuss the another classification of the Boolean algebra. That topic is called sub-Boolean algebra. Okay, in your lattice, you are started to classify the concept like sublattice. By the same way, here, Boolean algebra, next topic, what we are going to discuss now, that is sub-Boolean algebra. It's easy definition only. See here, B comma, that is actually your same plus and then plus star. Okay, plus star. Here, this is actually complement symbol, comma 0, comma 1. If it is a Boolean algebra, then if I denote one subset, S is the subset of B means, when can I say S is a sub-Boolean algebra means it has to satisfy only one condition, that is closure. Closure. Sorry. So it has to be a closed. If it is a closed, then we can clearly say it is a sub-Boolean algebra. Okay, I'll just explain here. Here the operations are the same, GLB and then LU. Okay, so usually instead of GLB and then LUB, they can denote in two ways. One is disjunction and then conjunction symbol, or they can use star comma plus. Okay, so also they are added one more value, that is 0 comma 1. What they trying to explain on this 0 comma 1? Why they have mentioned there 0 and 1? Any guess? Any guess? Any guess? Can you able to hear me?
Yes, sir.
Yeah.
Should the subset
Uh,
also have the same lower and upper bound, sir?
Very good. Very good. Superb. So the subset also should have the same 0 and then 1. Okay. So that means it is not required to have the same 0 and then 1, in which it should have the subset should have the greatest element and then least element. Okay, that can be any one of the element can play the role as the greatest element. Any one element can play the role as the least element. That does not matter. It's here 70-30 means the same number should not be repeated over on this. Okay, it can be any one of the value, but it should follow the property. It should not have the maximal and the minimal elements. Instead of that, it should have the direct greatest element, direct least element. Okay, so also they have defined that, they have used that dash symbol. That means it has to be a complement. Okay, so complemented lattice. So here you are going to just check whether the given set is sub-Boolean algebra or not. There you need to check only one operation, that is A star B. One more is A plus B. Okay, sometimes instead of star they can use A dot B also. That is not a problem. Okay, so here uh, so now in the next slide, we can enter into check whether the given sets, that is A and then B, A and then B, or sub-Boolean algebra or not. Here they are given the set D70, that means divisors of 70. Also in the question itself they have drawn by own like the Hussey diagram for the divisor 70. Okay, so in which the simple question is asked, check whether A and B are sub-Boolean algebra or not. Here your task is assigned there. You need to apply 1 star 7. Okay, my pen is not working. I don't know why. Anyway, 1 plus 7. Okay, by the same way, you need to apply all the pairs. Okay, if it follows the property, closure property, if the value also will belong to the A itself means, then you can confirm A is a sub-Boolean algebra. Okay. By the same way, you need to apply for the next subset B. Okay. So your task is assigned here. You need to check the closure property with respect to star and then plus between every pair of the elements which appeared in the both the sets. Okay. So if it satisfies the closure property inside the A, also if it satisfies the closure property inside the B means, then you can confirm A and B are sub-Boolean algebra. Okay. So have you cleared on these examples and then related definition? Is it clear?
Yes, sir.
Okay. Okay. I'm just sharing the attendance link. You just fill the attendance form parallelly. Meanwhile, I just rectify the errors which appear on my digital pen. Okay, I'll just connect you back. Stay connected. Okay, I'll just join you back in 5 minutes maximum. Hope you have received the attendance link, right?
Yes.
Yes, sir.
Yes. Thank you. Stay online. Okay. Can you able to see the screen?
Yes, sir.
Okay, thank you. Okay, now we can enter into discuss the another slide. So this is the way to check whether the sub-Boolean algebra exists on the given set. Okay, they will be provided the Boolean set in which they can denote the elements. So they can ask the question with the Hussey diagram. Your duty, you need to check is it satisfy the closure axiom for the subsets or not. Okay, if it is so, then you can confirm it's a sub-Boolean algebra. Otherwise, you can simply say it's not a sub-Boolean algebra. Okay, now we can enter into discuss the important session of this model. Actually, usually the following topics can be asked as a single 10 mark. So please keep an eye on the concept carefully. To solve the problems, it's very important to know the some properties. The properties are already know. The commutative laws means actually here the dot represents, instead of star only they are used dot. Sometimes they can use simply AB equal to BA. Okay. So that also it's considered as a star is there inside the A and B. So these are the notation. So idempotent laws means A plus A equal to A dot A. Okay, so likewise associative laws, distributive laws, absorption law. So this might be the new one. This is also already we take a look on that. So here, which variable is dominating twice the time, that will be the final answer. Okay, already we have discussed. So complements, this is also important. So complements means A plus A dash equal to 1. So A dot A dash equal to 0. Then A dash is the complement of A. Already we have discussed about it. So if you apply 0 dash means you will get the answer 1. 1 dash means 0. So De Morgan's law means just you brought the complement inside the bracket, that time A dash plus will be changed as dot. Okay, that means plus will be changed as star. If there is star means star will be changed as plus. That's it. So you can just simply bring the dash complement inside the bracket. That's it. This law is called De Morgan's law. This is negation law, or you can call it like a involution law. So involution law is nothing but if you take complement twice a time, you will get the answer retained as the same variable. Okay. For example, A plus B dash, again if you apply dash means you will get the answer what? A plus B whole dash, again you, dash means what will be the answer?
A plus B.
A plus B, that's it. Okay, so this is the way. So by keeping this table, we can solve the problems. Okay, we can solve the 10 mark problems. Okay, this table is very important. Anyway, we can switch over to another notebook software that will be the compatible one. Okay, so now we can solve this. Yes, this problem. Okay. Yes. So now the problem is as like transform the given this, actually this is called Boolean expressions. In this, it is going to transform as SOP. SOP means sum of the product. Sum of the product. SOP. They actually here it is of the form POS. POS means product of the form. Product of the form is nothing but see here all the terms are totally three terms. Okay, totally three terms. Three terms are in the product. Maybe it is not in the form, but you may have the term like this. Okay, you are going to convert this into a proper form, that is sum of the product. Sum of the product means you can have the multiplication between them. That means A, B, C, D, D, E. Okay, there inside the brackets, between the brackets, you will have the plus. That method is called sum of the product. There is another method. This is actually SOP. Okay. There is another method POS. PO is nothing but A plus B, C plus D, D plus E. This method is called POS, product of the sum. There you are applied product between the brackets. Inside the bracket you have the sum. Okay. Have you understood the two types, SOP and then POS? Sometimes they can ask you to convert SOP. Sometimes they can ask you to convert POS. Have you understood on this two method? Can we get into the problem? Is it clear? Is
Yes,
it clear? Okay, now we can step into the problem. Yes. So first one. See, in this, first you can start expanding this with respect to the complement symbol. So complement symbol means that I can write the first bracket like x1, x2 dash. Already dash is there. I'm going to apply one more dash. Okay, plus, because there is actually there are two terms A, B. I'm going to apply A, B whole dash can be expanded as A dash plus B dash. So here I have written A dash plus B dash, that is x3 dash. Have you understood this first bracket expansion? Is it clear? Is it clear?
Yes, sir.
yes, sir.
Next, we can move on to the next one. Here, totally, the complement has two terms. It is of the form A, B dash. So it is going to write like A dash plus B dash. That means x1 dash plus x3 as A. So A dash plus x2 dash plus x3 dash whole dash. Have you understood up to this?
Yes, sir.
Yes, sir.
Okay, now, by using the involution law, x1, x2 dash dash dash. So complement of complement will be vanished. So it will be remain same x1, x2 plus x3 dash. The first bracket gets over. Next, in the second one, so I can start writing this like it is of the form A plus B whole dash. So it can be expanded by bringing out the complement inside the bracket. You will get the form like x1. Can you just directly say the answer to on this bracket?
X1
Can
dot
you,
X3.
very good. X1,
And X3.
X3 dash
x3 dash. Very good. Okay, that's it. So now, can you directly say the second bracket answer?
X2, X3.
3.
X2. Very good. That's it. Okay. Now your processing is simply you are going to expanding this bracket like with respect to the first term x1 x2 into x1 x3. What will come? X1 x2 again x1 x3 dash. Next first term into last term, that is x1 x2 x2 x3. So the last process you need to multiply by x3 dash with the second bracket all the terms. So you will get the answer like x3 dash x1 x3 dash plus x3 dash x2 x3. So what will come? Here, can you just guess what law I'm going to apply on this? Now you can just take a look on the formulas what we have covered on the previous slide. Okay, you can just take a look on this table in which law I'm going to apply on this. That means
Idempotent.
very good. That's it. So that law is actually idempotent law. X dot x1 dot x1. So by the law, I am going to get the answer like x1 into x1 x1 again. So that is x1 x2 x3 dash plus. So here also I'm going to apply the idempotent law. So x1 x2 x3 next x3 dash into x3 dash, same x3 dash into x1 plus. Now can you just guess the answer for this last term? Same
X3 dash X1 plus 0.
Plus 0. Very good. Because the properties of complement says like A into A dash. That means if you take the multiplication between the element and then complement elements means you will get the answer as 0. So by applying the complement law on this step, you will get the answer directly right here like 0. Okay. After this step, you are going to apply furthermore simplification on it. Like from these two terms, I can take out the common term as x1, x2. So the remaining term will be x3 dash and then x3. Okay. Third term you can keep as the same without changing anything on that. So after that, now again you are going to apply the complement law on this step. What will be the answer? Any guess?
Dash plus 1.
X1, X2 plus X3
One.
dash.
Plus X3 dash.
So complement law, if you apply the addition between the element and then complement element means you will get the answer 1. If you
One.
apply the multiplication between the element and then complement element means you will get the answer 0. So by applying the rule, you will get the answer here x1, x2 plus x3 dash x1. Okay. Is there any other possibility to apply the simplification on it? Is there any other steps can be applied there to apply the simplification on it? Is it possible? Is it possible? No. Okay, very good. So here, what they're asking you to determine, you are going to transform the given confused form into the SOP. That means sum of the product. So can you just accept it? It is of the form sum of the product.
Yes, sir.
Yes. So you have got the desired answer. So that's it. Okay. Have you understood this 10 mark? Is it clear?
Yes.
Okay, fine. So next question. Okay, now we'll solve the next problem. Okay, 1 minute. So here in this, we are going to apply the same table values. You are going to simplify this. Actually, the last time this question was asked as a single 10 mark. So that's why I have taken this problem. So here, our task is assigned here. We are going to apply the simplification on it. Okay, one method, what we have discussed, they will be given the confused form. They can just ask in the standard form. That can be either in, they will be mentioned which form is expected to derive the answer, like SOP or POS. But this model says just you're going to derive the answer in a simplified form. Okay. Anyway, let us start with the first one. Okay, first we'll solve the first problem. Again, Boolean algebra method. So here you are going to expand it. Okay. So here in this case, x plus y. If I take y from this both the case, what will be the answer? Sorry, what will be the remaining one? 1 plus x. I mean, if suppose if the steps are confusing means nothing to worry. You can just apply the same method. You can start expanding the bracket. That's not a problem. Okay, so x into x plus x into z. Next, y into x. Next, y into z. X y x x y z. Okay, after this, what is the answer for the xx?
X, sir.
X.
xz plus yx plus yz plus xy plus xyz. After this term, I can take x common from the first two terms. So the remaining will be 1 plus z. Okay. Next, from this, yes, yx plus yz plus, from this I can take xy common. So remaining will be yz. Have you understood up to this step? Is it clear?
Yes, sir.
Okay. After this, what is the answer for this 1 plus z?
1.
1.
1. By using which law? I'll show that. 1 minute. See here, the bound property, by using the bound property, here if you add the greatest element with any element, you will get the answer. That means if you apply the GLB, that means GLB LUB concept only, bound property. So you will get the answer. A plus 0 means A plus 1 means 1. A dot 1 means A dot 0 equal to 0. You should keep in mind. Okay. So by using this logic, you can directly say the answer 1 plus. Next, yx plus yz plus, here also 1. So after this, again I can take x as common. So 1 plus y plus z, xy. After this, x plus yz plus xy. So in those two steps, I can take again x as common. So 1 plus y plus yz. After this, so x plus yz. Is there any other steps can be followed to apply the
Sir,
simplification?
in the third last step, we can xy plus xy, we can take it as 1 xy, no?
Sorry?
In in the fourth step,
Okay.
we have yx and xy. We can eliminate 1 xy.
Yeah, that's not a problem. Actually, here, that's what I'm wanted to say, that actually here it is not a unique procedure to get the answer. Your final answer will be the unique, but procedure to complete the answer can be the different one. That is not a problem. Okay, you will be followed some other method by taking here itself in the first step itself. If you start the process, instead of expanding the brackets, someone can do the process like in the first step itself, one person can take like x plus y can be taken as common, and then he will get the same answer. Okay, so that is not a problem. Here you can follow any one of the way. Finally, you will be reach the same answer. Is there any other mistakes I have done, or is it right? Is it
Correct,
right?
sir.
Okay,
Yes,
fine.
sir.
So if you follow this, actually, if you follow this method, the problem may be completed in 3 or 4 steps itself. The person also will be getting the same answer. Okay, that's it. So this is the way to determine the simplified Boolean expression answers. Okay. So any other doubts up to this?
No, sir.
No, sure.
Okay, fine.